Alright, so before we get started on the work, there's one more graph to show. I was getting ready to make your problems today, and I realized that there was one more that we had not seen. There are occasional graphs where the denominator is an actual factor of the numerator, and when you get that, that graph is a line with a hole at the illegal point. So we're going to go through that real quick before we go to I think I gave you 7 problems, yeah. So yeah, like I said, let's look at that real quick just to make sure we see what's going on. So when I look at this, first off, this is part of that family where the numerator is higher in degree than the denominator. But when I look at it and I think of, again, remember I said you should kind of assume that everything could be factored until you can't factor. I want numbers that multiply to be 5 and subtract to be 4. Those numbers are negative 5 and positive 1. So this actually turns into x plus 1 times x minus 5 over x plus 1. And so, in other words, whenever we divide it, even if you would have did a division, for example, and put a negative 1 in the box and put 1, negative 4, and 5, something weird happens because when you do this work here, it should be a negative 5. When you do this work here, you end up with a remainder of 0. And when you, in the ones we did yesterday, did not get a remainder of 0, which is why we actually had an oblique asymptote. You kind of still have an oblique asymptote. The difference is when this number is 0, it's not an asymptote anymore. It's an actual line of x minus 5, which is what you see here. 1 and negative 5 means it's x minus 5. And so what would be a typical vertical asymptote is no longer an asymptote because this graph just turns into that line. So what you will do is graph the line down 5, then up 1 over 1, being careful with the value of negative 1. So what you will do at the value of negative 1 is you will start at negative 1. How do I do this safely? And put a hole at negative 1 or where negative 1 is and continue your line. So that is what the graph looks like. Now I'm pretty sure this doesn't line up with negative 1 perfectly, but I did my best to show there is a hole because remember negative 1 is the value that breaks the function, so you cannot have a number there. But since it does divide evenly, you just end up with a line. Again, that would typically be my oblique asymptote from what we learned yesterday, but because it divided in evenly, your oblique asymptote just turns into a actual line with a hole in it. So just kind of keep that in mind as we go. Remember, again, the best way we learn is by making mistakes. As you saw, my presentation on the video of this lesson compared to the last lesson was so much better because of all the stupid mistakes I made. So we eventually learn from that stuff. Alright, so again, go ahead and pause the video. I'm sorry, you can't pause the video. Yeah, you have, no. The video is going to pause at this point. Sorry, I'm a little out of it at this moment. Alright, so if you were to graph this, first off, we got to recognize this is a family where the denominator is higher, which means that the, actually it's higher. Yeah, it's higher, so the vertical asymptote is still going to be just x equals 2. Alright, so it's just 2 because there's 2 of these things. 2 of these means it's x minus 2, which means I don't need to put both of them. The only number that breaks this is 2. The horizontal asymptote is going to be y equals 0 because there's nothing up here. Again, if there is a variable up here, if they were equal, remember you do the fraction, but the rule on whenever the family is here is that it's y equals 0. If you want a hint as to why that works, simplify this and write the leading coefficients down. So you have 4 on top, and the leading coefficient on the bottom after you square it out would be 4 over x squared. And what we learned is that x squared represents a very, 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 very big number. It turns into, well, if 4 was cut into a whole bunch of pieces, then it would be almost 0. Alright, so again, no matter what you do, if you pick the number all the way to the right, all the way to the left, it's going to be a very big number. 4 divided by a very big number is going to be as close to 0 as you can possibly get it. Alright, so anyway, going back to this graph, hopefully you got that part. X equals 2, I go over and put my asymptote here. And then you remember what I told you. Because there's only one asymptote, chances are it's going to be something here. We also, I think, learned that whenever it's squared, it ends up at the top. So if you have that picture already, you know you're in good shape. So what we now do is pick a couple of points and draw the graph. I will pick the value of 3. And again, going with what I learned, I suck at using a calculator, so I'm not going to use it. 4 over 3 minus 2, which is 1, which is 4. So 1, 2, 3, 4. And then I'm going to use the value of 1, which would be 4 over 1 minus 2, which is negative 1 squared, which is 1, which is still 4. So yes, we are right. And again, now you sketch a line that approaches both asymptotes. Again, you will probably bump into a teacher at some point as you go forward who wants you to get more than that, but I am teaching you the general idea because, I mean, specificity is different with every teacher, and I'm not going to give you a requirement of finding 17 points this time when we're sitting at home, and another teacher next year might only require 2 or 3 or 4. So I'm not going to work you to death this year, especially with us being at home and, you know, just kind of suffering with all the freedom from school that we have, because I'm sure you're dying just like I am and can't wait to get all the way back to school and get to work all the time. Again, video is going to pause at this moment. What you should have noticed here is that this is a family where the degrees are the same, which means your vertical asymptote still works the same. You look down here, you see that it's x equals negative 1. Your horizontal asymptote, hopefully you remembered looking at your notes, because remember you can use your notes, is that when they are the same, you take the leading coefficient, just like we did up there, over the other number. 3x over x is equal to 3. So y equals 3 is your horizontal asymptote, and so you take that information, and again, knowing what we know about this graph and what the shape is going to be, the only thing that happened was that our floor moved up. So same thing, pick some points, figure it out. I'm going to pick 1 to the left, which is 0. That'll be 0 minus 3, which is negative 3 over 0 plus 1, which is 1. So negative 3. That's crazy. When I choose 0, I get 3 times 0 minus 3, which is right, 0 plus 1, which is right. So let's trust it and hope we're right. Then when I do, oh, I know what it is because it flips around. Then when I do the value of negative 2, that'll be negative 6 minus 3, which is negative 9, over negative 2 plus 1, which is negative 1, which does make sense to me now, which is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 here. And again, looking at the behavior, pretty consistent. If you look from this line, 1, 2, 3, 4, 5, 6 jumps down versus 1, 2, 3, 4, 5, 6 jumps up. If you're wondering why this is reversed, I will show you that in just a quick second. And it's because a negative exists in this problem. Because if you factor this, you get 3 times x minus 1 over x plus 1. And if you remember, what we learned was that if we want to, actually no, you can't. Never mind. I was wrong. But that's the graph. Number 3, video is going to pause again. Once again, we should recognize this is where the numerator is lower than the denominator, so we do have vertical and horizontal asymptotes. The vertical asymptote is, oh, we need to factor this, don't we? That'll be x plus 5, x plus 1, so negative 1, and x equals negative 5. horizontal asymptote, because that's smaller, you would end up with x over x squared, which is 1 over x, which as we said is 0. So y equals 0. Again, because if you put a very big number here, that's going to turn into a 0 pretty much. And so we now go and put negative 1, 2, 3, 4, 5. And again, this goes to what I told you yesterday. I can see the shape of it because I know this is 1 over x. I remember that 1 over x is usually here and here. It's just a question of what goes on here. And again, that's where those quote-unquote mistakes came from. In our last lesson was my calculator plugging in was just terrible. Anyway, picking a point like 0. 0 plus 1 is going to be 1. 0 is a nice number because that becomes 0 plus 0 plus 5, which is 1/5. Yes, I agree. So that would be somewhere around here, which is really weird. Hold on. Aha. See? There you go. Because x plus 1, and hopefully you didn't make this mistake, you're better than your teacher, x plus 1 and x plus 1 are both factors. And so because they're both factors, that means that, and the reason why is because usually you don't get a weird number like 1/5. It'll be up here somewhere and it'll drop really quickly, at least in my brain. But x plus 1 and x plus 1 are both factors, which means that this is a whole, more than likely. So I think what happens is that I need to check a point like -2. So I'm going to plug this in to save some time. -2 plus 1 divided by -2 squared plus 6 times -2 plus 5. 0.09. 1/5 is 0.2. I wonder what's here. So let's do 1, 2, 3, -4. Oh yeah, I know where I messed up. If you look at my calculator, Mr. Bradley did not follow his own teaching. So -2, let's clear this out. Parentheses -2 plus 1 divided by parentheses -2 squared. That's probably where I messed up the day before. Plus 6 times -2 plus 5 is 0.3, and that does work better because that's 0.2. That's 0.3, which means it's going up. I'll check -4 because it's closer to the line, and it should be a higher number because I believe it's going to still just do that. So second enter, turn that to -4, that to -4, and that to -4, and I get the value of 1, which is exactly what I thought would happen, which is what's going to be is, and because you should already have the graph, it's going to do this, except when it gets to that point, because those two are factors, it's going to be a whole, and it's going to continue on. And then I am assuming, since that went up 1, this is probably going to go down 1. So if I turn this into -1, 2, 3, 4, 5, -6, there's your -1. There's the proof that my approximation was right. And there is your graph, or that's what it should look like. So again, minus the squiggle, that's what it should be. This is not an asymptote, and it's not an asymptote because both of those things matched. It will be a whole in that at -1. Whew. This is why your instincts need to be right, because again, what happens is you start plugging numbers in and you get a weird number like this, and you think to yourself, as I did, or you eventually think to yourself, as I did, which is, why is this 1/5? Why is it so low? Because again, usually it's got at least a little bit of space before it kind of goes up there. Video is going to pause now. We should recognize this where the numerator is higher, and so because of that, that means that we will need to find our vertical asymptote first, which is x equals -3, and then we need to do division. So I'm going to do -3 in a box with 3, 4, and -15. Bring down 3, that makes -9, this makes -5, that makes +15, and notice that there is a 0. Remember that this is not an oblique asymptote. That is a actual line. So in other words, what this means is that x plus 3 is actually a factor, which it is because I made this problem up. It's actually x plus 3 and 3x minus 5, which if you notice, if you multiply that out, you get 3x squared minus 5x plus 9x minus 15. There's your +4. So I made it that way on purpose, but hopefully you recognize that when you divide it, you got 0, which means it's a different problem, which is go down 5, go up 3 over 1, put your dot. Somewhere at this point should be a hole. Again, I'm not expecting it to be perfect. I don't think most teachers are, but go as far as you can. Put a hole in that graph and then continue. So again, it's a graph with a hole in it. That should look like a line. That was the new one that I just talked about today. Alright. Video's going to pause. And what you should notice again is that this is one where the numerator is higher than the denominator, and so what we will get is vertical asymptote again is x equals 2, because we go out and get that from the bottom. We have to now divide x squared by x minus 2, which means I can put a 2 in the box and I get 1, 0, 0, because if you remember, that's x squared plus 0x plus 0, because remember you have to do that part. Dividing this, you get 1, which turns into a 2, which is a 2, which turns into a 4, which turns into a 4. Again, we ignore that because we don't want it. Because that does not go in clean, you end up with the graph of x plus 2 as your oblique asymptote. And so now we go to where x is 2. And we draw our vertical asymptote. We then graph the line x plus 2, which means go up 2 and put a dot, up 1 over 1, put a dot. Use that again, because this is not going in clean, it's an oblique asymptote, which means it should look like this. So we now pretty much can see the shape, which is probably going to be like this. Again, I don't need 19 points. If you just get one and draw me a general sketch, I am fine. Again, I will tell you there are probably teachers who will want you to do more. I just don't need that under these circumstances. So we now pick a point like 3, and again, I think I'm doing much better without a calculator. So we're going to pick a point like 3, and that'll be 9 over 1, which is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know this is going to do something like that. And now pick a point like 1, because again, if the oblique asymptote is at 2, I'll pick 1. That makes 1 over -1, which is -1. Puts me here. Was 3, 1, 2, 3, 4, 1, 2, 3, 4. Yep. So then we have a graph that looks something like this, and that would be what you need. Video is going to pause. What we should notice here is that we have equal, which means again we go to our vertical asymptote. Hopefully we can factor this, and it is x minus 4 x plus 1, but when we factor this, it's x plus 1 x plus 2. And what we just learned in my dumb mistake earlier, again, that's why it's good to make them, is that these are the same, which means that that is a whole. So our vertical asymptote is at x equals 4, but there is a whole at x equals -1. Again, experience is a very good thing. Horizontal asymptote, because remember it does have one, is at whatever those two are, because they're the same. So x squared over x squared is equal to 1, so it's at y equals 1. So now we draw our graph. We go to x equals 4. We put a vertical asymptote. We go to y equals 1 and put a horizontal asymptote. We pick a point, pick a couple of points, and figure out what it is. 1, 2, 3, 4. So we're going to pick 5. And now that I have my confidence back with my calculator, because I know what dumb mistake I was doing, we do parentheses 5 squared plus 3 times 5 plus 2 divided by parentheses 5 squared minus 3 parentheses 5 minus 4, and I get the answer of 7. So 1, 2, 3, 4, 5, 6, 7. If I went 1, 2, 3, 4, 5, 6 up, I'm assuming I'm going to go down probably to -5. Let's see. Let's turn this into a, that's 4, so we'll turn that into 3. Cross our fingers and see if I actually know what I'm talking about for once. There's your -5. So 1, 2, 3, 4, 5 is here. And again, from there we know it's going to approach the asymptotes. We know we're going to get a graph. It looks something like this. Ooh, no we're not, because we forgot about one thing. The -1 was my whole, so therefore it would be a whole right there. Again, you're going to mess up, but you have to allow your instincts to kind of lead you to always ask, are you sure? Kind of in the background. It's kind of like a voice whispering, are you sure? Are you sure? The whole time. Now what some of you think is that that voice is making you crazy because it makes you question yourself, but you're always supposed to question yourself because you never know if that choice is right. And before you make a final decision, you should always ask yourself, are you sure this is right? So anyway, video is going to pause. Now again, this is one where the numerator is higher than the denominator. This does factor, and because it factors, it means that this is x minus 3x plus 4. And let me explain better now, because I actually am thinking about it now. The reason that there is no, it's just a whole, is because what we learn is that whenever, or what we should have kind of seen over these, if you go through it again, you'll actually, honestly, if you go through this video again with a scratch sheet of paper again and do it all over again, you're going to actually get better at this, because there's so much information in this video that just going through it's going to help you improve your skill. But what we should be noticing is that anytime that and that were the same, let me go back and see if I can find it. Yeah. Going back to 3, that was not an asymptote, because x plus 1 and x plus 1 are both in the numerator and denominator, so it's not an asymptote. Here, I said I had a vertical asymptote at x equals -3, but x equals -3 is actually in the factor, which means it is not an asymptote, it was a whole. So what we are trying to see, or what we should start seeing in the pattern, is that anytime the factors match is not an asymptote. So when I think that the vertical asymptote's at -4, it's not. This is actually just a whole, which means that that's why your oblique asymptote turns into a line, and the line that you have is x minus 3. So up 1 over 1 with a whole at -4. I'll try to remember that this time, somewhere around here. I just completely destroyed it. There we go. So if your graph looks something like that, then you did your job. Again, I guarantee you there is so much information in this that if you honestly just did this again with another sheet of paper and came back, I'd say at the end of the day, or at least a couple hours, 3 hours is usually about enough time to forget about everything you learned, or at least have life kind of cover up your memory a little bit. But if you were to come back 3 hours later, you'd probably forget most of what you saw, and going through this video again, except skipping through all the dumb monologues I have, would probably get you a better experience, and at least you would be able to see if you learned anything from your mistakes before. But again, if the numerator is higher, you have an oblique asymptote. If the numerator is higher and the factor matches, then you have a hole in the graph. If the numerator and denominator are equal, you simply take the leading coefficient. So if it was 5x squared plus something over, let's say 6x squared over 2x squared plus something, you would take 6x squared over 2x squared, and when you divide that, the x squareds cancel, getting the answer of 3. That would be your horizontal asymptote. And if it's a number over x, or x squared, then your horizontal asymptote is 0, because that number cut into millions of pieces is pretty much going to be 0. So hopefully we've kind of figured that out. Good news is we're moving on. But again, that's something that you're going to be expected to know when you walk into your next class. So I hope that I did not confuse the mess out of you, but I do think that we at least learned a little bit, because as we kind of put it all together, I think it, for me at least, it started to make sense. But that's coming from someone with a degree. So anyway, have a good day. Enjoy the rest of your day. Again, if you need another set of practice, come back after about 3 hours or so and see if, even if you just watch the video and mentally go through the exercise with me, I think it'll help also. So other than that, have a good day.